3423. One weather phenomenon which will always occur when flying across a front is a change in the A. Wind direction, B. Type of precipitation, C. Stability of the air mass. The correct answer is A. When flying across a front, one of the weather phenomena that will always occur is a change in the wind direction. A front is a boundary between two air masses with different characteristics, such as temperature, humidity, and density. As an aircraft crosses a front, it encounters these different air masses, which results in a change in wind direction. At a cold front, for example, the colder air mass is advancing and replacing the warmer air mass. The wind direction typically shifts from a southerly or southwesterly direction ahead of the front to a westerly or northwesterly direction behind the front. This change in wind direction is often accompanied by an increase in wind speed. Similarly, at a warm front, the warmer air mass is advancing and overtaking the cooler air mass. The wind direction usually changes from an easterly or northeasterly direction ahead of the front to a southerly or southwesterly direction behind the front. The type of precipitation and stability of the air mass can also change across a front, but these changes are not guaranteed and may vary depending on the specific weather conditions associated with the front. In contrast, a change in wind direction is a consistent phenomenon that occurs when flying across a front. 3451. During which period is a sea breeze front most suitable for soaring flight? A. Shortly after sunrise, B. During the early forenoon, C. During the afternoon. The correct answer is C. A sea breeze front occurs when cooler air from over the water moves inland, replacing warmer air over the land. This process is driven by the temperature difference between the land and the adjacent body of water. The sea breeze front typically develops during the afternoon hours when the land has been heated by the sun for several hours. During the afternoon, the temperature over the land is usually at its peak, creating a larger temperature contrast between the land and the sea. As a result, the sea breeze front becomes more pronounced and defined, providing better soaring conditions for gliders. The sea breeze front can generate rising air currents or thermals along its boundary, which can be utilized by soaring pilots to gain altitude and extend their flight time. These thermals are often strongest in the vicinity of the sea breeze front, where the warm air from the land meets the cooler air from the sea. Therefore, for soaring flight, the period during the afternoon when the sea breeze front is most developed and active is the most suitable time to take advantage of the rising air currents and maximize the soaring potential. 3385. Which weather conditions should be expected beneath a low-level temperature inversion layer when the relative humidity is high? A. Smooth air, poor visibility, fog, haze, or low clouds. B. Light wind shear, poor visibility, haze, and light rain. C. Turbulent air, poor visibility, fog, low stratus-type clouds, and showery precipitation. The correct answer is A. A low-level temperature inversion occurs when there is a layer of warm air aloft, which acts as a lid, trapping cooler air near the surface. When the relative humidity is high, several weather conditions can be expected beneath this inversion layer. Smooth air. The presence of a temperature inversion often leads to stable atmospheric conditions, resulting in smooth air with minimal turbulence. Poor visibility. High relative humidity combined with a temperature inversion can lead to the condensation of moisture, resulting in reduced visibility. Fog, haze, or low clouds may form in these conditions, reducing visibility further. Fog. The stable conditions associated with a temperature inversion can promote the formation of fog, especially if there is sufficient moisture in the air. Haze. High humidity levels and temperature inversions can contribute to the formation of haze, which consists of suspended particles and moisture in the air, reducing visibility and creating a hazy appearance. Low clouds. Inversion layers can lead to the formation of low stratus clouds, which are typically flat and horizontally extensive. These clouds can be found beneath the inversion layer and contribute to reduced visibility. Overall, When a low-level temperature inversion is present with high relative humidity, pilots can expect smooth air conditions but should be prepared for reduced visibility due to fog, haze, or low cloud. 3403. What measurement can be used to determine the stability of the atmosphere? A. Atmospheric pressure. B. Actual lapse rates. C. Surface temperature. The correct answer is B. Surface temperature can be used as a measurement to determine the stability of the atmosphere. Stability refers to the tendency of the air to either remain in place or to rise or sink when disturbed. It is an important factor in weather forecasting and aviation as it influences cloud formation, turbulence, and vertical air movements. By observing the surface temperature, meteorologists and pilots can gain insights into the stability of the atmosphere. There are three main types of atmospheric stability: stable, unstable, and neutral. Stable atmosphere. In a stable atmosphere, cooler air is located near the surface, and temperature generally decreases with increasing altitude. This temperature profile inhibits vertical air movements and promotes calm, smooth conditions. Stable conditions are often associated with clear skies, limited cloud development, and reduced turbulence. Unstable atmosphere. In an unstable atmosphere, warmer air is located near the surface, and temperature generally decreases at a faster rate with increasing altitude. This creates an environment where air parcels are buoyant and tend to rise freely. Unstable conditions can lead to convective activity, such as thunderstorms, as the rising air parcels can reach their condensation level and form clouds. Turbulence is more likely to occur in unstable conditions. Neutral atmosphere. In a neutral atmosphere, temperature changes with altitude are relatively small or non-existent. This means there is no strong tendency for air parcels to rise or sink. Neutral conditions can occur during transitional periods between stable and unstable conditions. Surface temperature observations, along with other atmospheric parameters such as lapse rate, the rate of temperature change with altitude, and atmospheric moisture content, help determine the stability of the atmosphere. This information is valuable for weather forecasting, flight planning, and understanding atmospheric conditions. 3404. What would decrease the stability of an air mass? A. Warming from below. B. Cooling from below. C. Decrease in water vapor. The correct answer is A. Warming from below would decrease the stability of an air mass. Stability refers to the tendency of the air to either remain in place or to rise or sink when disturbed. In a stable air mass, cooler air is located near the surface, and temperature generally decreases with increasing altitude. This temperature profile inhibits vertical air movements and promotes stability. When the air mass is warmed from below, such as by the heating of the underlying surface, it disrupts the stability by creating a more unstable environment. The warmer air near the surface becomes buoyant and tends to rise. This upward movement can lead to the formation of convective currents and vertical air motions. As the air rises, it expands and cools at a slower rate than the surrounding environment. This can result in the formation of clouds, precipitation, and potentially thunderstorms if other favorable conditions are present. The process of warming from below destabilizes the atmosphere and can lead to more turbulent conditions and the development of convective activity. Cooling from below, on the other hand, would enhance stability as it creates a stronger inversion layer and inhibits vertical air movements. A decrease in water vapor alone would not have a significant direct effect on stability, but may influence the overall moisture content and potential for cloud formation. Understanding the factors that influence stability is important for weather forecasting, aviation, and other applications that rely on understanding atmospheric conditions and their impact on air movements.